Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 4, Topic 3, Part 2. 1. Interpreting control charts. When analyzing control charts, operators look for specific patterns, trends, or signals that may indicate process instability or special causes of variation, including a. Points beyond control limits. Data points falling outside the control limits signal the presence of special causes of variation that warrant investigation and corrective action. b. Trends. Sustained upward or downward trends in the data suggest systematic shifts or changes in the process over time, requiring further analysis to identify root causes. c. Cycles or patterns. Repetitive cycles or patterns in the data may indicate seasonality, periodic fluctuations, or other sources of variation that need to be addressed. d. Run rules. Various run rules or statistical tests, e.g., runs above, below the mean, consecutive points increasing, decreasing, help identify non-random patterns or sequences in the data that may signal process instability. 1. Challenges and considerations. While control charts are powerful tools for process monitoring and improvement, several challenges and considerations should be taken into account, including a. Data accuracy and consistency. Control chart effectiveness relies on the accuracy, consistency, and reliability of the data collected and entered into the system. b. Sample size and frequency. The selection of sample size and frequency impacts the sensitivity and responsiveness of control charts to detect process variations and abnormalities. c. Process complexity. Complex or multi-stage processes may require the use of specialized control charts or subgrouping strategies to effectively monitor and control process performance. d. Operator training and interpretation. Proper training and education are essential for operators to understand control chart principles, interpret chart patterns, and take appropriate corrective actions when needed. 1. Future trends and innovations. As semiconductor packaging manufacturing continues to evolve, the adoption of advanced technologies such as artificial intelligence, AI, machine learning, ML, and predictive analytics holds promise for enhancing the capabilities and effectiveness of control charts. 1. These technologies enable real-time data analysis, anomaly detection, and predictive maintenance, allowing for proactive quality management and process optimization. In conclusion, control charts are invaluable tools in semiconductor packaging manufacturing, providing a systematic approach to process monitoring, analysis, and improvement. By establishing control limits, detecting special causes of variation, and facilitating continuous improvement initiatives, control charts help ensure product quality, reliability, and efficiency in semiconductor packaging operations. However, their effectiveness depends on proper data collection, interpretation, and operator training, as well as ongoing efforts to leverage advanced technologies for enhanced process control and optimization. Thanks for watching. Please like, share, and subscribe.